Hello guys, welcome to the Doubtlet. So in this video tutorial, we are gonna discuss that how to solve the sum for a telescoping series. Means it might not be given in a question of convergence divergence that whether we have to solve that particular question by telescoping series. But there are some cases that we have to keep in mind, and from those cases we can easily determine that we have to solve all those problems by telescoping series. So here we will discuss some examples and try to solve them one by one. So this is the first example. Means this is a series and we have to find whether it converges or diverges. If it converges, then what is the value? So this is the under root minus and this is the square root of k plus 1 minus square root of k. Then if we will directly put the value of k as 1, so what we will get here? We will get minus root 2 minus root 1. Then in the next expression, if we will put k is equal to 2, then what we will get? We will get here 3 minus under root 2. Then again k is equal to 3. What we will get? We will get 4 minus under root 3. Then this term of k will lead to infinite. So suppose let k is equal to k. So what we will get here? We will get k plus 1 minus under root of k. And if we will add all these terms, because summation means addition, so definitely we can see a pattern here that this number is cancelled by this number, then this number is cancelled by this number, so the left term is remaining in the end. So when we will cancel the n k minus 1th term with the kth term, then this term will be cancelled and this term will be remaining. And here the final term is infinite. So here we have to find the limit. So limit k tending to infinite, and we have to find the value of this last term at infinite value. So we can write this as under root of infinite. It means we are getting the last term as infinite. So if we will subtract this root of 1 from infinite, then what we will get? We will get infinite. So it means this series is divergent, and we have solved this series by the telescoping series method. So this is the first example that we have discussed. Now we will discuss another example of another type. So here this is a series from k is equal to 1 to k is equal to infinite 1 upon k into k plus 2. So means the numerator degree is 0 and denominator degree is 2, because this is a quadratic equation in factored form. So what we have to do? We have to use the again telescoping series to solve this problem, but we have to use partial fraction decomposition method to write this in the factored form. So just let's write a upon k plus b upon k plus 2, and if we will just take the LCM k into k plus 2, so what we will get? We will get ak plus 2a plus bk is equal to 1 divided by k multiplied by k plus 2. So this denominator will be cancelled out. So if we will compare, so here the coefficient of k is 0, but here in the RHS the coefficient of k is a plus b. So a plus b is equal to 0 and 2a is equal to 1. So a value is 1 by 2, then b value is minus 1 by 2. So we can write this k 1 upon k multiplied by k plus 2 as 1 upon 2 divided by k minus 1 upon 2 divided by k plus 2, right? And if we will take 1 by 2 common from this, so what we will get? 1 upon k minus 1 upon k plus 2. Now replace this term with this term. So the constant term will be thrown out of the summation. So we have to find the k is equal to 1 to infinite 1 upon k minus 1 upon k plus 2. So if we will put the value of k is equal to 1, 2, 3. So let's suppose put k is equal to 1. So what we will get? We will get 1 upon 1 minus 1 upon 3. Then we will get k is equal to 2. So 1 upon 2 minus 1 upon 4. then k is equal to 3. What we will get? 1 upon 3 minus 1 upon 5. Then put k is equal to 4. So what we will get? 1 upon 4 minus 1 upon 6. And this process will goes on to infinite. So for k is equal to k, what we will get? 1 upon k minus 1 upon k plus 2. So here we can say that this 1 by 3 will be cancelled out, this 1 by 4 will be cancelled out. Again these all term will be cancelled. And here what we have got? We have got 1 by 1 and plus 1 by 2. So if we will sum all these terms, 1 plus 1 by 2. So here we can say that this term is cancelled, then this right term is remaining. If this 1 by 4 is cancelled, then this one is remaining. And in the last one, the right term means 1 upon k plus 2. This term is remaining. And we have to find the limit for k to infinite. So 1 plus 1 by 2 is remaining, plus limit k tending to infinite 1 upon k plus 2 means minus 1 upon k plus 2. Since this is in the denominator, so this term will cease to exist, means value of this will be 0. So finally the value of this series is 3 by 2, means this series converges and its value is 3 by 2. So this is how we have solved this another type of telescoping series problem. Now just taking another example, means I have just listed all the problems of different type, means they are not of similar type, but the method is similar of telescoping series. So again here is summation n is equal to 1 to infinite cos 3 divided by n square minus 3 upon n plus 1 square. So we will directly put here. So for n is equal to 1, what we will get? Cos 3 upon 1 minus cos 3 upon 4. For n is equal to 2, what we will get? Cos 3 divided by 4 minus cos 3 divided by 9. Again n is equal to 3, what we will get? Cos 3 divided by 9 minus cos 3 divided by 16. And so on, we will put the value of n is equal to n. So what we will get? We will get the same expressions as given in the question. Cos 3 divided by n square minus cos 3 divided by n plus 1 का whole square. Now we will cancel out the terms. So this term will be cancelled out. So the left term, so right term is remaining. So again this will be cancelled out. The right term is remaining. So all the terms will be cancelled out, but the right term will be remaining. So cos 3 is remaining and this term is remaining. And here we have to check the value of this last term at limit n tending to infinite. So cos 3 divided by n plus 1 का whole square. So if we will put infinite in denominator, then this term will become 0. So we can write this term as 0. So cos 0 value is 1. So the final value of the series is cos 3 minus 1. So this is the answer. So cos 3 value will be also it is a number between minus 1 to 1, and this is also a number. So it means this series is convergent. So there might be a convergent series or divergent series that we can got from the telescoping series method. So now we will just check out the last example of this video so that we can learn about the concept of telescoping series in the better way. So let's try to solve this. So 2 is the constant, so we can throw out this. So here we can use partial decomposition method, or you can directly use your common sense also. Like if we have to write the 2 in the form of 2k minus 1 and 2k plus 1. So let's suppose if we will write 2k plus 1 minus of 2k minus 1. Then if we will solve this, then definitely we will get it as 2. And if we will divide this by 2k minus 1 multiply by 2k plus 1. So we know that in fraction, if we solve this a minus b divided by ab, then what we will get? A divided by ab minus, I cannot write on the right side. So let's suppose we have to solve this expression in the algebra. So we can break this like a upon ab minus b upon ab. So if we will solve this further, then what we will get? 1 upon b minus 1 upon a. So similarly we can break this. So if we will break this for k is equal to 3 to infinite, so we can write this as 2k plus 1 divided by 2k minus 1 multiply by 2k plus 1 minus this is 2k minus 1 divided by 2k minus 1 multiply by 2k plus 1. Correct? So 2k minus 1 will be cancelled and 2k plus 1 will be cancelled. So we will get the form of telescopic series from here. So this is 1 upon 2k plus 1 minus 1 upon, sorry, here this will be cancelled out, 2k plus 1. So 2k minus 1 will be remaining. So we can write this as 2k minus 1 and this is 2k plus 1. Now we know that this is the form of telescoping series. Now we will put the value of k starting from 3. So if we will put k is equal to 3, what we will get? We will get 1 divided by 6 minus 1 divided by 7. Again we will get k is equal to 4. Then what we will get? 1 divided by 7 minus 1 divided by 9. Again we will write k is equal to 5. Then what we will get? We will get 1 divided by 9 minus 1 divided by 11. So it will go on to infinite. So the last term will be, so for k is equal to k, what we can write? We can write this as 1 upon 2k minus 1 and minus 1 upon 2k plus 1. So if we will just add all these terms, so this term will be cancelled out, so right term will be remaining. This term will be cancelled out, so right term will be remaining. Again this term will be cancelled out and this term will be cancelled out and the right term will be remaining. So after adding all these terms, what we will get? We will get 1 by 6 minus limit k tending to infinite and minus, this is minus, so we will use it plus here. So plus 1 divided by 2k plus 1, right? So since k is in denominator, so this value will be 0. So we can write this as 1 minus 6, 1 by 6 minus 0 is 1 by 6. So we can also say that this series is convergent by telescoping series method and its value is equal to 1 divided by 6. So this is how we have solved all the different, majorly I have covered all the types. So if you still want to ask any other doubt in the telescoping series method, then please mention your doubt in the comment box below or visit my website and post your doubt there. I hope you would like the video. Please share it with your friends so that I can get a better feedback. Thank you very much.